Okay, getting things set up, waiting for everyone to join in. By everyone, I hope it's a bunch of people, but we'll see. Good morning, Madeline. Just getting things set up over here. I was a little chilly this morning, so I'm wearing my big puffy comfy coat. Uh-oh, Lily wasn't first today. She's slipping. I hope everybody had a wonderfully restful weekend. We're just going to give the slackers a few more minutes to show up. I'm sure they all had to get their puppy coats too because we were all chilly this morning for some odd reason. Bum, bum, bum. Bum, bum, bum. All right, everybody. You got less than 2 minutes, then we're gonna get rolling with it. If there's a bunch of you or none of you. And that is time, ladies and gentlemen. So we are gonna get rolling here. Today's topics will include multi-step linear inequalities, compound inequalities, and making sure everyone makes their own bed. Well, at least I hope that last one happened before you logged in to view this, whether it's on the replay on YouTube or live here on Zoom. So, without further ado, Algebra 1 students, let's get into solving some inequalities. Okay. All right, let's look at this one. Get my math practice standards out. Okay. So, first thing I need to do is just make sure I'm understanding this problem. So, let's just make some sense here. Okay, so it says I need to solve for z. Okay. Reduce any fractions to the lowest terms. Don't round your answer, and don't use mixed fractions. Okay. So I read the directions, and then I got, whoa, what is this thing? Okay. Okay, so I guess the first thing we should broach is what is the difference between this inequality and an equation? So an inequality is going to function very similar to an equation. Let me go ahead and write out the two different things, and then I'll show you the difference. So here is the inequality we were given. Negative 4z plus 31 is greater than or equal to 17z plus 23. And I have to go back and select this. Let's see if this works. Nah, it didn't. Okay. So I just need to manually draw a line. 1 second. So negative 4z plus 31 is greater than or equal to 17z plus 23. Okay. So if we're going to compare that to an equation, so if this is negative 4z plus 31, it equals 17z plus 23. Got to be careful about how far over I go, or else you won't be able to see this on YouTube. Okay, so generally speaking, our steps are not going to change. However, the inequality symbol, this greater than or equal to symbol, the one I'm highlighting right now, this guy right here. Okay, so we're to solve this the same way we would be solving an equation. However, this inequality is going to make us really keep track of a few different things. Let me explain. So I don't have any like terms to combine. So what I'm going to do is I'm going to add 4z to both sides. And I'm also going to, let's see, if I'm moving my constants, if I'm moving my variables to the right side, let me go ahead and move my constants to the left side. So I'll take away 23. Now, again, this is just in the equation form of this problem. So my abstract rules, again, reason abstractly. So my abstract rules say that anything plus its opposite makes 0, so that cancels out. Anything plus its opposite makes 0, that cancels out. So what am I left with? Well, 31 minus 23 would be 8. 17z plus 4 would be 21z. If I add 4z, yeah. If I subtract 23, yep. So I'm pretty sure I'll divide by 21 on both sides, and I'll end up with a fraction. Now, it said reduce any fractions to the lowest terms, but so it's expecting you to have fractions. So 21 and 8 can't be divided by anything. So apparently, again, abstractly, 21 divided by 21, that's equal to 1. So we should end up with 8 over 21 is equal to z. Now, this is how we would solve it if it was an equation. Okay, that's just an if it was an equation. That's what it would look like. Now, watch how we're going to solve it, even though it's an inequality. And it's going to be pretty much the same for this problem in particular. So I would, I'd add 4z to both sides, just like I did if it was an equation. I would subtract 23 from both sides, just like if it was an equation. The reason I'm doing either of those things is because negative 4z plus 4z, they're opposites. That makes it 0. That's my abstract rule. And then let's see, 23 minus 23, that makes 0. Again, that's an abstract rule. I guess I should also point out that I'm making use of structure here pretty heavily, and I'm very careful. I'm attending to precision. So what I am left with, 31 minus 23 is 8. Is greater than or equal to 17z plus 4z, that'd be 21z. So if I divide both sides by 21, 21 divided by 21 is equal to 1, so you basically have 1z. So you might notice a similarity between the inequality answer and the equation answer, and that is basically the work is the exact same. Let's just see if I didn't make any boo-boos. So let's do 8 over 21 is greater than or equal to z. It took it. Yeah. Okay. So essentially, solving these inequalities is not that much different from solving an equation. You do the same inverse operations, you're abusing the same abstract laws, and you're producing an answer. But there is going to be a case where that inequality flips around, and that is the only way these get different. Let me see if the next one produces a situation like that. So what we're looking for is anytime we have to multiply or divide by a negative number, that will cause our inequality to flip-flop. And I'm intending to work on these until we get one that does that. Otherwise, you won't think there's any difference between these and equations. Okay, so here we go. First thing I'm gonna do is I'm gonna rewrite this guy over here. So that is negative 32c plus 12 less than or equal to negative 66c minus 16. And then I'm going to quickly underline this because it is inclusive, greater than, or I guess it'd be exclusive. It's less than and equal to? No, it's inclusive. Okay. So let's talk about scrap work. I can't combine any like terms because this has a C on it and this does not. This has a C on it. This does not. Now I want to make things positive if I can engineer it that way. So what I'm going to do is I'm going to add 66C. That's the opposite of this onto both. So that'll make these cancel out and make a 0 because if you're adding opposites, where's my math practice standards? Okay, so reason abstractly. So if you add opposites, you get 0. Okay. Now I'm also going to be, because I've got all the C's on the left side now, so let me just go ahead and take away 12 from both sides. So these cancel. So negative 32 plus 66. Well, it's going to be their difference, but the answer will be positive because the positive number has greater magnitude. It's farther away from 0. So 66 minus 32 would be 60 minus 30 is 30. I think it'd be 34. So we got like 34C. Negative 12 and 12 make 0. So it's less than or equal to. This makes 0. Now, negative 16 minus 12. Okay, negative 16 minus 12 will be negative 28. Okay. So now this is one of those where it's not going to end up pretty, but we're not going to have to flip this around and see. What I'm going to end up doing here is dividing both sides by 34. So the reason I would do that in the first place is to get these to cancel each other out. So now I'm left with 1C. And we didn't have to multiply or divide by any negative values, so I'm left with negative 28 over 34. Now this can be simplified a little bit. And is that they are both even. So what's another way we can write that? Okay, so if we divide them both by 2, it'll be the same as negative 14 over 17. I guess that's what we're going to try and hope for the best. So negative fraction 14 over 17, see how it goes. Okay. I love this. Now I get to backtrack and see where I goofed up. Live on YouTube for all to see, nonetheless. Okay, so negative 32c plus 12 less than or equal to negative 66c minus 16. Okay. So I add 66c to both sides. That makes 0. 34, choose the difference. Yeah, okay, I agree with that. Less than or equal to. Oh, I didn't actually finish writing out the inequality. Maybe that's all I needed to do. C is less than or equal to. Oh, yeah. Awesome. So I did everything correct, and then I just didn't write out the entire answer. Smart guy. Okay, well, at least I can live with that. That's a smart guy mistake. I won't let that happen again. That goes back to repeat it. So I just had a math practice standard 8 moment, repeated reasoning. I'm not gonna let that mistake happen again. Especially since I did all the work correctly. Okay, we're still looking for the white whale. The problem where the inequality is going to flip-flop because we have to multiply or divide by a negative. If it doesn't happen, it doesn't happen. But I sure am hoping it happens, because why else would we be doing this? Okay, let's roll. Write down. So that'd be negative 67b plus 6 is less than or equal to 9b plus 43. Got to remember that this is an inequality that is less than or equal to. Okay, inverse operation times, time to get the b's by themselves. Why don't I go ahead and add 67b just so we get positive values. So if I'm adding 67b, that'll take care of that, because now these make it 0, so they're gone. So I can take away 43 from this side, so I get all the constants. Those are numbers with no variables on the other side. So it's going to be kind of ugly, but it's all right. So these cancel out and make it 0. So what are we left with? We are left with 6 plus a negative 43. So that's going to end up being negative, goodness. 6, 43 minus negative 37 is less than or equal to 9 plus 6, 70. Oh, goodness. 76. 76b. 9 plus, that makes sense. And now we would divide both sides by 76. It looks all kinds of gross, but it's just the way the mechanics work. So apparently, since 76 divided by 76 is equal to 1, so apparently negative 37 over 76 is less than or equal to, whoa now. Is less than or equal to b. Okay. I've got an idea as to how to show you how this flip-flop works, because if you've been watching my videos, you'll notice a pattern. I always try to make sure that my values come out positive. Just one less thing to worry about. So when it comes time to use my abstract rules for adding and subtracting opposites, I always pick the one that makes sure I'll end up with a positive value on the other side. And I think on this one, I'm going to purposely not do that so you can see how you need to flip-flop your inequality symbol if you don't do it my way. So let's start with this inequality, which is negative 23d plus 81 is less than or equal to negative 98d plus 1. Check it. Negative 23d plus 81 is less than or equal to negative 98d plus 1. Okay. Underline that. Excuse me. Okay, so for whatever reason, let's just say I decided to add 23d to this side and add 23d to this side, okay? Let's just say I decided to do that. It's perfectly legal. I'm doing the same thing to one side as I am the other side. It should work out. And I would have to do this. So that way, these cancel and make a 0, and these cancel and make a 0. And when I sum everything up, so 0, 81 minus 1 is just 80. It's less than or equal to, now negative 98 plus 23. Well, that'd be 70. I guess it's negative 75d. Well, that's kind of nice. We can divide both of these. 80 and 75, they can both be divided by 5 at least. So 80 divided by 5, what is that? 5 goes into 40 8 times. This is double that. So I think it'd be 16. Yeah. So 16 is less than or equal to 75 divided by 5. 5 goes into 50 10 times. You need 25 more. So I guess it'd be 15. So it'd be negative 15d. Okay. 15, 25. Yeah, okay, that's right. Now here comes, okay? This is the big moment. If you could stop and pause and focus, put your stuff down, listen. We're about to make this inequality flip around, and here's what's going to happen. We have to divide by a negative 15, get d by itself, which in and of itself isn't the end of the world. We're just dividing by a negative number. But because of that, this is going to have to flip. And that the reason that is happening, this has to flip because we divided by a negative value. It works the same as if you multiply by a negative value, because division and multiplication are basically the same discipline. But anytime you multiply or divide by a negative, the inequality flips around. So what we end up with as an answer would be negative 16/15, but it's going to be greater than or equal to d. So we flip the symbol around. There it is. So that's what we should get. So it's negative, it's a fraction, it's 16 or 15, and that is going to be greater than or equal to d. Okay, so I'm just going to type this out on the screen to make sure we're all very, very clear. about what I just did. Let me get all this stuff. Okay, so here's the rule. When working with inequalities, you must flip-flop the symbol if you multiply or divide by a negative number during the process. That's the law. The moment I divided by a negative 15, my symbol had to flip-flop. Okay? And that's it. That is the only real rule here that makes this different from solving just equations. So that is something we're just going to have to keep in mind for the rest of this session, the rest of your life, whenever you're working with inequalities. You solve them the exact same way you do equations. If you add an opposite, you'll get a 0. If you divide by the same value, you get 1. And you can use these skills to navigate. But if you ever multiply or divide by a negative value, your symbol has to flip. That's the only extra rule. So imprint that and you'll be all right. Okay, there's one more lesson I wanted to work on today. That's called compound inequalities. So let's see if we can make sense of this. So we're given two inequalities at the top and then a bunch of stuff. Okay. Well, I guess the first thing my instinct here is to write down. Okay, so I've got this inequality and I've got this inequality. So let me just go ahead and try the first one. Okay, so 12x plus 7 is less than negative 11. That's what it said. Okay, so if I just do the work we've been doing for the past half hour, I could subtract 7 from both sides and get 12x is less than negative 11 minus 7 be negative 18. Then I can divide both sides by 12. Again, I haven't divided or multiplied by a negative yet, so the symbol stays the same. So what we're left with on the left side is that x, I should have been marking, yeah, so these make 0, this makes a 1. So what are we left with? We're left with x is less than negative 18 over 12. Those can be reduced. If you divide them both by 6, wouldn't it be negative 3 over 2? Okay, so far I like this. X is less than negative 3 over 2. Okay. So now the other one does not shrink very well. All right, so the other one is 5x minus 8 is greater than 40. And I mean, I guess I would just add 8 to both sides and end up with 5x. That makes it 0 is greater than 48. So then I could divide both sides by 5. And again, I'm not dividing by a negative number, so the symbol does not have to flip. That only happens when you divide or multiply by a negative number. So 5 divided by 5 is 1. So we end up with x is greater than 48 fifths. X is greater than 48 fifths. So I'm going to have to go with A on this one. Let me see if any of these others line up. It's always good to double check all your answers. So X is, okay, so, all right, so X is greater than 3 over 2. No, I don't like that one at all. X is greater than negative 3 over 2. Nope, that's not it either. It can't be all, it can't be none. Okay, so I'm just going to stick with that. I'm going to stick with that and see what happens. Yeah, okay, it came out right. Sweet. Okay, since I'm flying solo, I'm going to do one more and probably call it a day here. So this, again, is compound inequalities where I've got to work with one and work with the other and then see which one of these answers kind of matches what my scrapbook says. So here's one inequality. I'm highlighting or boxing in purple. And here's another one I'm boxing in a light blue teal sort of color. So let's try the purple one first. So negative 7x minus 50 is less than or equal to negative 1. Negative 7x minus 50 is less than or equal to negative 1. Okay. Well, if I was to add 50 to both sides, I would quickly get this negative 7x. I haven't done anything to it yet. Negative 50 plus 50. Aha, that's where I created a 0, which is good. Is less than or equal to, okay, negative 1 plus 50 be 49. Okay, it's going to happen. Okay, now watch. I have to divide. I have to divide by a negative 7. Oh, there it is. Okay, so anytime during an inequality, if you divide by negatives or multiply by negatives, you must flip the symbol. So divide by negative 7 on both sides. So these cancel. This is going to flip. So what we end up with is this. So we end up with just x, flip this, is greater than or equal to, and 49 divided by negative 7 is actually negative 7. It's herself. So x is greater than or equal to negative 7. I like that. X is greater than or equal to negative 7. This is also part, that is the same thing. So I guess what we got to do is we got to try this teal one to see if it's less than 12. So let me go ahead and type it out. So negative 6x plus 70 is greater than negative 2. Negative 6x plus 70 is greater than negative 2. Okay. Well, if I were to subtract 70 from both sides, I have negative 6x. These are opposites, they make nothing. Is greater than, and then negative 2, that'd be negative 72. Oh, and here's, it's going to happen. Here it is. So when I divide by negative 6, bingo. That's going to have to flip. So let's see. Divide by the same thing, that's equal to 1. So what we end up with is just x, flip this around, is less than negative 72 divided by negative 6 would be just 12. Negative divided by negative is positive, so 60 plus 12, yeah. 60 plus 2 times. So x is less than, aha. So check that out. I actually like B because both A and B, A and Z are represented. Okay. So what have we done today? We've talked about compound inequalities, where you got two different inequalities. You have to sort of work with them both and see which answer matches which scrapwork says. We talked about multiple step inequalities, which require you to solve them kind of like you're solving equations, but because there's an inequality in the mix, you have to be careful anytime you either multiply or divide by a negative number, because that's going to make your inequality flip around and face the other way. What I need you to do, guys, once you finish watching this video, because I know you will, please find some that confuse you in your lessons, on your assignments, screenshot them, send them to me, or log in for tomorrow's session and talk to me about it live, because I want to help you. I really do. And the vast majority of sixth period is doing great. Their work looks good. But there are some of you where it's just not getting turned in, and maybe that's because you don't understand something. So I'm here. I'll send out remind codes to, I'll send out remind messages, and I'll post more invites to these Zoom sessions, but I really just want to be here to help you. So if you need anything, contact me. Take care of yourselves, take care of your family, and I'll see you next time.